How's it going, guys? Welcome to the third Arduino tutorial in which we're going to look at a very interesting device, which is a shift register. And in our case, it's going to be the 74HC595, as you can see on the screen. So what this IC does is that it is able to shift multiple outputs. So by using 3 pins on the Arduino, we're able to control 8 LEDs. And to just give you an idea of what this IC can do, you have a small scrolling example for the 8 LEDs on my breadboard. For this particular tutorial, you're going to need an IC, so a shift register. The one that I'm using, I'm going to link to the data sheet down below. You can buy it almost anywhere, SparkFun, Amazon, eBay, DigiKey. You're going to need some jumper wires. As you can see, I have a lot of them on my breadboard. You're going to need some current limiting resistors, which we've discussed in a previous video. You're going to need a bunch of LEDs. These are just very basic LEDs. And you're going to need a breadboard as well as your Arduino. Without any further delay, let's take a look at the data sheet for our IC. Alright, so here's the data sheet for our 74HC595 shift register, and as you can see, we can find a bunch of valuable information. I'm going to post this link down in the video if you want to get a more detailed view. You get all the pinouts, you get the layout for our device, which pin goes where, but more importantly, we get a description for every pin. So as you can see, we have, these are Q1, Q2, through Q7. Those are the pins that we're going to use to light up the LEDs. Actually, it starts with Q0, which is on the other side of the IC versus all the other ones. But we got these function descriptions within this table, which are going to allow us to basically configure the device as we want, and you will see later on how we're going to program this based on these. But in a nutshell, what you want to do is look at these different functions and decide what you want to do, or what you need the device to do. So in this case, we would like to shift a value. So in this case, they're setting an input of high into the shift register, and as you can see, it says contents of all shift register stages are shifted throughout, which means that basically you're cascading each element into the next one and shifting a new one into the shift register. Also, the very important function is, as you can see, contents of shift registers are transferred to the storage register and parallel output stages. What that means is you have shifted in your values at this stage, but you need to actually instruct the device to output what you want, so basically the final result, to light up the LEDs. And the way this table works, as you can see, they have a description of what's going on. So here it's if you go from low to high voltage on your SHCP pin, and you're going to keep these as they describe, you're going to execute this function. And in this case, if you go from low to high on the SDCP pin, you're going to execute this instruction. So this is obviously very important, and it's going to play an important role in the programming for this device. Lastly, what else do we want to see? Also, from this diagram, we can notice that the enable pin is basically just allowing us to either display basically have an output or not have an output. Also, the MR, the master reset pin, has to be constantly high for us not to reset the values completely. So those 2 pins could just be a set value in our case, and we don't need to worry about them. So essentially, we're going to be using 3 Arduino pins to control 8 outputs, or 8 LEDs in this case. Alright, so let's start writing the software. Alright, so let's start defining our 3 pins. The first one is going to be the DS pin. The DS pin, let's set it up on pin 8 of the Arduino, and SDCP. And once again, all these pins are defined in the data sheet. So if you want to reference anything back and see what they do for yourself, feel free. We are going to declare our setup. So this is as usual. You always have to do this for the Arduino. Pin mode. All of these pins are going to be outputs, obviously. Output. SDCP. HCP. We're going to declare a function, so write reg function. We're also going to set up a registers array of 8, since we're going to have 8 pins. What else? So let's declare our function. Write reg. Okay, so in this function, what we're going to start with is digital rate SHCP pin to low. What this does is we're going to start basically initializing all of our registers one by one. So we're going to set this pin to low. We're going to declare a for function in which we're going to declare I is equals to 7. So we're going to insert register values in a reverse order. Get to 0. X minus. So in this for loop, we're going to shift in the value that we have stored in the registers array one by one. So in order to do that, we will start by a digital write of the SDCP pin low. We're going to write the value of the register. So in this case, digital write DS pin, and here we're going to pull the value of the register. So write registers I, and then digital write STCP pin to high. So as you can see, we're creating this sort of low to high transition here. So STCP goes low and STCP goes high, and this is what I mentioned in the datasheet, that we're trying to get that transition to call that basically function of the IC. And we're going to close the function with a SHCP pin to high. So once again, anything in between these two, you get the transition of the SHCP pin from low to high. So this is going to basically save our values and output them onto the register. So as always, void loop, get open, close. And in our case, I created a very simple double for loop, which will cascade the LEDs. So let's just do that. Int I equals 0, I smaller than 9, I plus plus. Within the for loop, what I'm doing basically is declaring registers high one by one. So registers I is equal to high, followed by a delay, followed by registers write reg. So our function, which is going to write the set registers, and another for loop, which is going to be int I equals 8. So obviously you want to reverse the LEDs, so to make that like wave pattern. I bigger than 0, I plus plus, open, close, just gonna close the for loop. Okay, and here it's going to be basically the opposite. So registers I low, delay 100, and write the register. Let's see if we get any errors. Digital write, write. There we go. Okay, so that works. Let's upload it to the Arduino, and we're going to take a look at what we've got. Alright, so I just wanted to take a look at the circuit that I built and sort of explain what's actually going on. So as you can see on the right, we have the IC, and we have the connections that are made to the Arduino. So obviously your VCC or ground, you have to connect them. So ground, VCC. The master reset, as I explained earlier, has to be pulled high in order for us not to basically clear the register. So that's just permanently pulled up. The pin that's grounded is here. It's the enable, and if you look in the data sheet, it's an inverted pin, so that's why it's grounded. It's instead of pulled up, but in reality, it's actually being pulled up inside the shift register. All the other 8 Q0 to Q7 pins are connected to an LED through a current limiting resistor, and I've explained how to calculate these values before, so if you want reference those tutorials. The pins 8, 9, 10 are our Arduino pins 8, 9, 10 are connected to SHCP, STCP, and the DS pins. So we're inputting the register value through the DS pin, and we're toggling these inputs in order to perform certain functions described in the data sheet for this device. So let's take a look at the actual circuit and how it performs. Alright, so as you can see, the breadboarded circuit, we have all our, this is Q0, that's going to the first LED, and this is Q1 through Q7, which goes to each LED. They're all plugged in with a series resistor, and all of them are grounded, just like I explained in the schematic. We got power and ground going to the Arduino board. So the white wire here is the ground, the red is the power, and we have 3 control wires going back to the Arduino pins 8, 9, and 10. And as you can see, we are shifting through our LEDs, and they're going up one by one, then going down just like we wrote in the software. So feel free to modify the software, showcase what you've got. Let me know if you have any questions. Make sure to comment, subscribe. That would be very helpful, and let me know what else you would like me to make in the following tutorials. Thank you guys very much. Hopefully you enjoyed this third tutorial. Thanks. Bye.